Assalamu alaikum brother. Today I will show you how to create a splitless method for your GCMS sample. So when you open the software, this TurboMash software will show up like this. We will first create a GC method, then we will create the MS method. Okay, so for creating GC method, you come here and click on this. Then you come here, create new method. Okay, here you add the description of your method, what it's relate, and uh, something about your samples, so you add up here. This will also, when you are saving your method, so this name will be saved automatically, so choose this name wisely. Then come here, cap GC. Okay, then click OK. So this is the interface. Now we will create a journal method that will work for almost any samples. So the initial temperature I add here 50 degrees C and hold it for 1 minute, and then the rate will be 3 degrees C per minute, and I will take it up to 300. My column, the column which is fitted in the GC, can withstand up to 350 degrees C. So that's why I'm taking this up to 300 degrees C. So the whole time will be for this is let's suppose 0.66 minutes. No, 0.67 minutes. Now you see here our runtime is 85 minutes. So this program will work for almost any volatile compounds because the initial temperature is low, the hold time is less, and the rate of temperature is slowly given, and it will go up to 300 degrees C and it will stay there for 0.6 seconds. Okay, the whole end time is 85 minutes. Okay, now come here to the injection temperature. Injection temperature, we will always take injection temperature less than 5 degree less than the final temperature of the oven. So the final temperature of the oven was 300 degrees C, so now we will put here 295 degrees C. So by doing this, when we inject our sample will be exposed to this temperature, and it will all the volatile compounds will be shifted to the column. Okay, and hold here for 999 minutes, infinite time. Now injection. Now come to the carrier. We will set here the flow of helium. So we are now setting 1 ml per minute for 999 minutes. Okay, now come to the detector. Now the fun part is here, how to make your program splitless. So you have to come here, instrument and events. Okay, you see the time is 0. Then you come to event. When you come to event, select SPL1. Okay, SPL1, the value should be 0. Now we add the events. When you add event, this first event will be like this: SPL00. Okay, now we add second event. Second event will be 19 and time will be 0.05. Okay, when you add this, it will come like that. Now your program, your method becomes a splitless method. Okay, now click on recheck again. This is the oven temperature, 50 degrees C, hold for 1 minute. With the rate of 3 degrees C, it will go to up to 300 degrees C and hold there for 0.67 minutes. The carrier is set. Okay, the detector and the events is set. Okay, now change the values over here. It will equilibrate in 0.5 minutes. Change the value over here, and the length of a column, we have a 30-meter column. The diameter is 250 micrometer and the flow is 20. That's why we put 19 SPL1. Okay, so when you put 19 SPL1, all of your sample will be transferred to the column, and after that column your all sample will be shifted to column. It will not go in a splitless mode. It will not go in a split mode. Okay, now apply this and okay, now you have created a splitless method for your program. Now save it with a name. It's called journal method and the time here is 85 minutes. So we will put journal method 85 minutes and SPL less, splitless. Okay, now put OK, write the name GM journal method 85 minute splitless. Okay, save here. Now you see the method is saved with the name this. Now we have created a GC method. For the MS method, you come here, this, click it, this kind of window will open. You go to file, new, now MS scan. Now you see here our GC method was 85 minutes, so we will create the same MS method of 85 minutes. Okay, so you put 85 over here. If you want to change these, it will go to from 20 to 600. The instrument which we have, your instrument may vary. Okay, now we will add a solvent delay of 3 minutes. Almost every solvent evaporates under the 3 minutes. Okay, so add a solvent delay after 3 minutes, and when you start run your GCMS, your source will be in a sleep mode for 3 minutes, and after that after 3 minutes it will start reading sample. So any solvent peak will be skipped in under these 3 minutes. Okay, now save it with the name same like the MS method. Okay, save as, you write journal method GM 85 minute 85 3 SD 3 minutes solvent delay. 3SD means 3 minute solvent delay, or if you write 3MIN, so you will be able to remember this. Okay, now we have created two methods. Then how to run your sample with those methods? You see here, you add 1. Now when you click over here, find your method 85 minutes, this one, and find your GC method, this one. Okay, now write the sample name. Sample name, whatever, for example your sample name is ABC. Okay, you select all those. Now go to here, save it, and then you press this button. When you press this button, the instrument will send these two methods to the machine, and the machine will start equilibrating with your given method specifications. Okay, then when the light over here is ready, the journal status of the GC is ready, and the journal status, both of them are, when both of them are ready, you can inject your sample. Okay, thank you very much. If you have some other questions, kindly ask me. Thank you.